You can do everything right. Buy the expensive seeds, hire the labor, haul the heavy bags of fertilizer, and still watch your neighbor pull a massive harvest while your crop struggles to keep up. The issue often lies in how the plant actually receives its nutrients. When you apply standard granular DAP, a massive portion of it never actually reaches the crop. Up to 65% of those granules simply sit in the dirt and harden into useless stone. Looking at this cross-section, we see a process called soil fixation. As granular pellets dissolve, the surrounding soil geometry locks the phosphorus away. The nutrients are trapped, leaving the root system starving right next to the fertilizer you paid for. Relying solely on that traditional broadcast method is essentially guesswork. It leaves the plant waiting for weeks to absorb critical nutrients, precisely when its immediate demand is at its highest. To bridge that gap, modern operations use water-soluble NPK fertilizers. These are 100% pure nutrient compounds, completely free of the filler materials that clog up the root zone. By dissolving them in water and spraying them directly onto the canopy, you create a biological shortcut. The nutrients bypass the soil, entering the plant's vascular system through tiny pores in the leaves called stomata. Within 24 hours, the plant is actively feeding. You can achieve a similar targeted effect through drip fertigation. Instead of coating the leaves, the system delivers that pure liquid nutrient directly to the active feeding zones of the root structure. Agriculture operates on strict timelines. If a crop is expending energy to build a piece of fruit today, it requires the caloric intake today, not 2 weeks from now when a granule finally breaks down. Matching that speed requires a precise chronological schedule, starting between days 15 and 30. This is the vegetative stage, and the required grade is 19-19-19. It acts as an early-stage growth formula. With a perfectly balanced 19% split of nitrogen, phosphorus, and potassium, it provides the exact structural building blocks needed to push even canopy expansion and establish early foliage. But the rule for this starter grade is strict. Apply it only in the beginning. If you spray 19-19-19 after the flowering stage has triggered, the plant will waste its energy continually pushing out new, useless leaves instead of setting fruit. Moving into days 30 to 45, the crop enters the branching phase. Here, the schedule shifts to the 12-61-0 formulation, technically known as monoammonium phosphate. The massive 61% spike in phosphorus is intentional. It forces the plant to aggressively expand its subterranean root webbing. That dense, deep root network is the biological mechanism that guarantees a thick main stem and robust tuber development. Everything done in these first 45 days is strictly about engineering the chassis. The goal is to build the physical architecture required to support the heavy weight of the mature crop later in the season. Pre-flowering, we shift to the 0-52-34 formula. Nitrogen drops to absolute 0, phosphorus hits 52, potassium 34. Depriving nitrogen is a deliberate trigger. Vertical growth immediately halts. All stored energy is forcefully redirected to multiply and reinforce flower clusters so they don't drop. Once those flowers successfully set, the timeline advances to the grain and fruit filling stage. The required application here is 13-0-45, or potassium nitrate. At this point, the leaves have done their job synthesizing food. The high dose of potassium acts as a bulk transporter, rapidly pulling those stored carbohydrates out of the foliage and packing them directly into the fruit or grain to maximize its final weight. By cutting and spiking specific nutrient ratios on this exact timeline, a grower effectively overrides the plant's natural biological priorities, forcing it to focus on yield over simple vegetative survival. There is one final component to this process: calcium nitrate. It acts as the structural reinforcement, fortifying the plant's cell walls to prevent stems from snapping under heavy loads and stopping fast-growing fruits, like tomatoes, from splitting open. But applying it comes with a strict chemical boundary known as the jar test rule. Calcium nitrate must be kept completely isolated. If you mix it into a tank containing any phosphate or sulfate-based fertilizer, the reaction is immediate. The chemicals undergo precipitation. The expensive liquid solutions instantly curdle into a thick, solid white mass, completely neutralizing the nutrients. Precision requires strict environmental parameters. The concentration must remain between 1 and 5 grams per liter of water to avoid salt burns on the leaves, and spraying should only occur before 10 a.m. or after 4 p.m. when the plant's stomata are open. Chemical errors at this stage can be devastating. A curdled tank mix will irreversibly plug expensive drip lines, and a poorly timed spray can permanently scorch the foliage of an entire field. The common hesitation regarding this timeline is the upfront cost. Sourcing premium, highly soluble NPK grades requires a higher initial outlay compared to buying bulk bags of traditional urea. However, field trials in wheat show these targeted sprays increase grain weight, adding 2 quintals per acre. At current rates, that generates 4,000 to 5,000 rupees in profit, achieved with a spray cost of just 500 rupees per acre. Securing the correct chemistry functions as a highly leveraged financial input, yielding returns that far outweigh the purchase price. Because of that value, the market is full of counterfeits. But real, pure NPK is easy to verify. It stays completely dry and crumbly to the touch, and if you drop a spoonful into water, it will fully dissolve within 30 seconds without any stirring. Maximizing a harvest requires moving beyond bulk soil applications. Success depends on delivering the precise chemical compound in the exact amount on the specific day the plant needs it most.